So what's good, everyone? Welcome to another lesson in statistics and probability. So we are still in chapter 5. We are now in lesson 2, the steps in hypothesis testing. So there are two main objectives that we are planning to hit. That is to identify the parameter to be used given a real-life problem, and then to formulate the appropriate null and alternative hypothesis. There are also three sub-objectives that we are planning to hit, which is to illustrate level of significance and corresponding rejection region, appropriately apply the steps in hypothesis testing, and to calculate the probabilities of committing an error in a test of hypothesis. So guilty or not guilty? Let's say we are in a courtroom and we are investigating the case of former President Marcos' ill-gotten wealth. The following picture there is the picture of the Supreme Court of the Philippines. If you are investigating any case in a court of law, we have two steps that we generally follow. The first one is to state the accusation or the statement of what will be evaluated as true or false. So dito binabanggit ng korte kung ano yung charge against you. What are your hypotheses? So your null hypothesis would be the accused is not guilty, and your alternative hypothesis would be the accused is guilty. Next, step 2. Based on the evidences, reject or accept the hypothesis that the accused is not guilty. The second step is to state the decision rule that we will follow in making the decision on whether to reject or fail to reject, accept the null hypothesis. In a court proceeding, it is a guideline that the court uses to evaluate the quantity and quality of evidences to be presented. And based on this guideline, the court decides whether to reject or fail to reject, which is accept, the hypothesis that the accused is not guilty. So with this, how can we make the decision rule? So your decision rule is composed of three. That's your level of significance, your test statistic to use, and then your rejection region. So the first one is to specify your level of significance. Recalling your level of significance, it's the alpha level from your confidence level. A level of significance is the probability of rejecting a true null hypothesis or the type 1 error. You can also compute for this level of significance. Next step is to identify the test statistic to use in the decision rule. The test statistic is a standardized expression of the point estimator of the parameter identified in the hypothesis. Kung z-test ba, kung t-test ba, kung chi-square ba, ANOVA ba, Cronbach alpha, etc. Third one is to specify the rejection region. So the rejection region is the part of the distribution of the test statistic where we reject the null hypothesis. So an example of a completed decision rule is as follows. At the given alpha or level of significance of 0.05, we reject the null hypothesis if the computed test statistic denoted as T sub C is greater than a tabular value of the T distribution with n-1 degrees of freedom. Otherwise, we fail to reject the null hypothesis. So in this given example of a decision rule, we can easily see that there is the level of significance and the test statistic to use, which is the t-test, denoted from the t-table. So how about the rejection region? Your rejection region is identified as follows. If you have your alternative hypothesis with your parameter less than the value, your rejection region falls on the left tail. If you have an alternative hypothesis where you have the parameter greater than the value, kung kanina left tail, ngayon right tail tayo. Your rejection region falls on the right tail of the distribution. How about if we have an alternative hypothesis having parameter not equal to the value in symbols? So we have two rejection regions, one on the left, one on the right. So we now have a two-tailed distribution. Summarizing the three, we have parameter less than the value, your rejection region on the left. If you have a parameter greater than the value, your rejection region on the right. And then if you have a parameter not equal to the value, you have a two-tailed distribution with your rejection regions on the left and on the right tails. So we have now discussed the first two steps in hypothesis testing. The first one is your hypothesis. So you state your null and alternative hypothesis. Kanina, that's the accused is guilty and then the accused is not guilty. Now, for the second one, the decision rule. The three parts of the decision rule: the level of significance, the test statistic to use, and then your rejection region. All in all, there are 5 steps in hypothesis testing as follows. You have step 1 to formulate the hypothesis. Step 2, state the decision rule. Step 3, compute for the value of the test statistic. Step 4, make a decision whether to reject or fail to reject the hypothesis. And step 5, state the conclusion. So now let's move to the examples. We are just going to focus on the first 2 steps in hypothesis testing, which is to state your null and alternative hypotheses and to state your decision rule. So for the first one, we have here a research claims that the average daily number of personal messages that a grade 11 student sends is at least 100 messages. A random sample of 16 students were interviewed how many text messages they send in a day. If the sample mean is 102 personal messages with a standard deviation of 5 text messages and approximately normal distribution, is the claim valid? Going on to our first step, which is to state your hypothesis. Let's first look at what is the claim or conjecture or statement that is to be tested. So we have there the claim that the average daily number of text messages that a grade 11 student sends is at least 100 messages. Remember that your null hypothesis is the claim or conjecture to be tested. Put that claim in your null hypothesis. Then your null hypothesis will become the average daily number of text messages that a grade 11 student sends is at least 100. If we have the word at least, ibig sabihin, pinakamababa na ang 100. In symbols, that would be mu greater than or equal to 100. So if you have the symbols of mu greater than or equal to 100, your alternative hypothesis would be mu less than 100. So from that, we can say that our alternative hypothesis is the average daily number of text messages that a grade 11 student sends is less than 100. Siyempre, kung hindi siya at least 100, meaning 100 or greater than 100, it can only be less than 100. So that is it for your step 1. Moving on to your step 2, which is to state the decision rule. So since in the problem, there is no set level of significance, we can compute for the level of significance by computing for the probability of committing a type 1 error. Recalling that a type 1 error is rejecting a true hypothesis. So let's compute for the level of significance. You have there your alpha equals the probability of rejecting the null hypothesis when or if the null hypothesis is true. So that would be, ano yung null hypothesis mo in symbols? That's mean, or you can also write there. So ano yung mean na you have gotten from your sample? It's 102, di ba? So ilagay mo yun sa reject HO, papalitan yun ng sample mean greater than or equal to 102 kasi we're testing at least. And then, null hypothesis is true. If your null hypothesis is true, ang ilalagay nyo doon sa baba, kung ano yung kiniklaim ng null hypothesis. Your mu is equal to 100. Computing for the probability, you have your z. Greater than or equal to, copying from the symbol sa null hypothesis. And then you have the formula of sample mean minus population mean. All over the fraction standard deviation divided by square root of sample size. So after computing for the value using the formula, we now have 102 minus 100 all over the fraction 5 over square root of 16. Because your sample mean is 102, your population mean hypothetically is 100, you have your standard deviation of 5 and a sample size of 16. Kasi we have collected from 16 students. Applying that formula, we have the value probability z greater than or equal to 1.6. And then you have alpha is equal to 1 minus the probability and then the symbols was switched. This is the process of getting the z value from your z table. So recall on that, then you would arrive at this answer 0.0058. Meaning that your right tail has an area of 0.0058 and the rest of the distribution having an area of 0.9452. If we have the alpha of 0.0058, our confidence level would be 94.52% or 0.945. So I won't ask for us to compute for the level of significance. This is because in researches, usually we just set the level of significance or we just specify the level of significance. But if you want to be as accurate as possible in statistics, you can compute using this formula. Now we have the two steps. The first one is to state your hypothesis, which is given as follows. And then your step 2 is to state the decision rule. We have computed for the level of significance, which gave us a value of 0.0058. The second part to determine is the test statistic to use. To determine that, look at your sample size. We have a sample size of 16 students. So your 16 students is less than the rule of thumb 30 as your sample size. So if you have a sample size less than 30, we use the t-table under t-test. Next, the third part is to identify the rejection region. The rejection region can be determined from your alternative hypothesis. So your alternative hypothesis here in symbols is mu less than 100. If you have a parameter less than the value, you have a left tail distribution with your rejection region falling on the left. So the colored part here in your normal distribution on the left side, that's your rejection region. Ibig sabihin, pag ang na-compute mong value ay greater than 100, it will fall on the acceptance region. So you're going to accept your null hypothesis. Pag ang na-compute mong value ay less than 100, say 98 or 90, you are going to reject your null hypothesis. So from that, constructing your completed decision rule, we have at alpha equals 0.0058, we reject the null hypothesis if the computed test statistic is less than the tabular value of the t-distribution with n-1 degrees of freedom. Otherwise, we fail to reject the null hypothesis. Here is a hypothetical example where we have your alternative hypothesis as greater than. Di ba kanina less than? O, paano ngayon pag greater than? If you have an alternative hypothesis with a greater than symbol, you can compute for your level of significance by computing for your type 2 error or your beta error. You can pause the video here and study the computation. Again, I won't ask for you to compute for the level of significance. So that is it for our first two steps. State your null and alternative hypothesis and then your decision rule, which is composed of your level of significance, your test statistic to use, and your rejection region. Again, here are the steps in hypothesis testing. We have tackled on the first two, formulate the hypothesis and to state the decision rule. For the next lessons, we're going to do the steps 3, 4, and 5. So that is it for our chapter 5, lesson 2 done. So have you memorized the steps yet? I would probably do memorize them because we're going to apply them more than once in our succeeding lessons. So I'll see you on our next video.